the way, we're going to have doing exercises, you might have questions, or you might be stuck at some point. If you are stuck in something, you put this orange sticking out in the top of your laptop, like here. And then Mike will go around, or myself will go around, and they can help you out. And then when we're doing exercises, as you accomplish a thing, you put the green one on top, so then that way we know that we can kind of move on if we have at least more than half of the people. So I'm going to leave it like maybe 2 more seconds. We can get everyone create an account there, because this is going to go in a few seconds. So yeah, can you get maybe everyone that has created successfully an account, put the green sticky note out. So you see that.
Browse around installing Spider-Man.
Yeah. That's good. A good chunk of people.
Yeah.
If you're having any troubles, put the orange one up, or like raise your hand, that will also be valid. This one personal.
This one personal.
Yeah. Oh, it's just a maybe.
Is this the
One comment, the email had the code in it.
Yeah, I don't know why. I think
Went to spam.
Is that an A?
Oh,
or an
for some people the email went to spam.
It's an
Okay, so
AL
maybe check your spam.
lowercase l?
It shouldn't go,
Is
but
this where I'm
I will report that back
That's right.
to some people that work on this technology. So I will track that now, so don't forget.
You got, let's see, B, WBL.
Oh, 3.
You're missing.
There we go.
There you go.
Got it. Cool. Just transcribe it.
So yeah, if you're having trouble, it sounds like some folks got the email in spam. If you can create an account for some strange reason, we won't have a plan B for those that might be struggling, but like, I'm hoping that everyone can get it. So,
Does it matter what we put in the account name?
sorry, what?
Create the NVIDIA cloud account, provide a cloud account name.
No, it shouldn't. Like, it should just be, for now, just like the email and create the account, then to access things that we're going to be able to do some other stuff. But
I was wondering what this step.
Yeah, this is the mystery.
So it's account name. So form asking for account name.
account name? Oh, let me see. Really?
Set up with user account.
Green is good.
More.
Yeah, green is good.
It's like, no, because we have an org name, but let me see if,
Yeah, not everybody's getting that.
oh,
Well, we use Google.
Like
that.
I was going to say, the grab it like that.
You just put PyData in?
yeah, maybe I don't.
What's the org name?
Give me 1 second.
You're right. So it's
I'll wait for an answer.
Yeah.
I am beta technology.
So is the fun part.
Does it matter? The people that was able to get in, does it matter when you put an account name or?
People are just putting PyData in when they got to the right.
Yeah, just put something in there, doesn't matter. We're gonna be able to get to somewhere. It wasn't like that when I did, or maybe they switch up the.
Oh yeah, it didn't matter. I got into the right place.
Okay, yeah, but it might be your name, and it's not being helpful, but, all right, so, now, let's go to this GitHub repo. I'm gonna leave it there for 2 seconds, so. We're gonna launch some stuff, and then while we wait, I'm gonna do some talking, while we wait for hours. If you even Google Rapids AI-community tutorial, that might be also an easier way to get there. So I'm gonna go there. So it's up here. I'm gonna make this bigger, so everyone can see that. When everyone is here, go to this Deploy Now button. You're gonna see there. I'm gonna leave the repo up in a second, and hit here where it says deploy launchable. And then once you're there, go to instant page, and you should see something that says deploying or whatever. Leave that going.
It'll take a bit.
It will take a bit. It will take like about 10 minutes. So I will like be doing some talking for a few minutes, and then we'll go there. Has everyone gotten to this stage? Just in case the repo name is this one. Over there.
Believe it or not, this is so much easier than it used to be.
No, don't. Just you just need to do the deploy launchable. When you click deploy launchable.
What's the tab? I don't see it.
In the repo, sorry.
Were you ever?
In the repository that you were, this one, and here,
Just go back.
there is a button here that says deploy now.
Yes.
Hit that and then do deploy launchable. All right. So while we get there, put the orange sticky note up if you're kind of getting stuck, and then Mike will go around. But we're just going to talk for a little bit, and then we're going to get to use some GPUs. So after all that kind of setup, hopefully everyone is kind of getting some GPUs at some point. Thank you everyone for being here today with us. We want to kind of talk a little bit more about what is to do GPU accelerated data science for PyData users. And my name is Clementi. I am a senior software engineer at NVIDIA. And Mike over there, he's my boss.
There you go.
He's a senior manager from the Rapids team. And so hopefully today we're going to get to see some GPU stuff related to Python, and then by the end of it, you will learn how to do some things on GPUs that hopefully will be an easy transition of what you're used to doing in day-to-day. So before we get kind of started, can I get a quick show of hands of who has ever run code on a GPU? Okay, we got like maybe 10 out of, we might be about 40, 50 people. Okay. How many of you think that you need to know CUDA and C++ to use a GPU? Well, okay, only one person. Everyone else knows that you don't need that. Okay, how many of you like write Python in your day-to-day code? Okay, pretty much everyone. Can you get hands on, do you do mostly like, let's say, pandas work? Okay, nice, good chunk. And scikit-learn? I also love that. So we got kind of like, good chunk. Do people use like PyTorch, XGBoost, kind of those stuff? Okay, a little bit less people. How many of you have heard of NVIDIA Graphics libraries? Okay, 1, 2, not many. Well, you're going to learn about them today. So a little bit, just like a little background so that I can kind of fill in this time while we get the GPU going, is one important comparison is like in the CPU you get like one or more serial processors, which is take like a single instruction and then they kind of from a stack execute sequentially. And then on the GPU, things look a little bit different. And you kind of get like a form of like co-processor that have one or more streaming multiprocessors, and all of these are a bunch of words I'm telling you, probably you don't know what I'm talking about, but which they kind of like in arrays of instructions and executes them in parallel. So GPUs executed in parallel a bunch of things at the same time. Well, for some reason the video is unavailable, but let's see if we can go to, okay, it doesn't let me see this video, but this was a cool video about, is it Mythbusters? Let's see if we could put this up. Okay, yeah. It's probably, commercials or something like that. Okay. Well, might not happen, but, I don't want.
Yeah, can you click play?
Maybe it's not allowed.
Is it not?
Okay.
There it is.
Well, I don't know if the sound.
You gotta click that.
Yeah, no, it's just not coming. But
It's okay, let's go watch.
what we're gonna do is, let's see. Okay, this is how like you will draw a picture with a CPU, like it's like a one point at a time, and it's just gonna have this robot that is shooting paint into the wall, and like as a comparison, so we'll go all that and get that, yay. Now, if you get, this is like a 14-year-old video, but they built this machine, which is powered by GPUs.
And everything.
Yeah, and like the idea is to kind of show what you can do with it with a GPU. So now is that when they hit, let's see, I don't want to spoil it, but they're going to kind of like shoot some stuff. Okay, come on, hit the red button. And then you get, okay, like a piece of art that is kind of allows you to do like a bunch of pixels at a time. And then that's sort of like the idea behind a comparison between like a CPU and a GPU. Now, all right. But so how do you control the GPU? And I think sometimes like we don't get a grasp of, say, like a GPU is on its own, it just kind of naturally function. You can think of executing code on a GPU like if you execute code in a second computer over the network. Like, have you ever like SSH into a machine, into a cluster, or something like that? You kind of have to move things from your laptop or whatever is it to that kind of server, and then in there you will do some stuff, maybe you run some simulation, and then you get your data back. That whole like moving things around, it's what happens between the CPU and the GPU when you're kind of trying to do some data analysis or training models or whatever. So you can think of it as a way to log in and execute programs on a remote SSA machine. And the way that you control that GPU and doing all the stuff is that you need to use CUDA or PCI, and then you need to kind of move the data and the code to that device to be able to do the tasks. But you will think, okay, but what is CUDA? Do I need C++? What's a kernel? What if you just like live on Python land? You just write Python code and you don't want to worry about that. Well, NVIDIA has been like developing several libraries across multiple years, and you could go and write all the C code if that's what you're comfortable with, and kernels, and then be really, really, really close to the metal, and then being able to do that. But maybe that's not what you need, and then you have several levels of abstraction where you can kind of be closer to what you're comfortable writing. So on the top we have zero code change acceleration plugins, which is you have your pandas code, your scikit-learn code, your networkx code, and you just give them a flag, and it will run on the GPU whatever it can, and whatever it doesn't, it will default to the CPU, but you don't need to change your code. Maybe then you want to get in something that is more like hybrid, and then like you can do like CPU and GPU libraries with minimal changes, and you get like, we get into maybe something more like TensorFlow, XGBoost, and things like that. cuML, CPU, and GPU are also kind of equivalent. And then we got libraries that are very similar in the API, like what you will be used to pandas or scikit-learn, but they're like their GPU Python code, and then in there you have like cuDF and cuML, and these names are similar for a reason. And then we can go deep down into like kind of get into the raw kernels and things like that. You could still write CUDA kernels in Python, and then if that's something that you're interested, at the end I'll give you links of materials where you can explore all that. We're now going to be touching into that. So today we're going to talk a little bit more about the GPU Python libraries, and then about zero code changes acceleration that you can get. So there's a lot of documentation, there's a lot of libraries. You can always search for like Rapids AI, and then you will see all that. There's like docs and of the several libraries and stuff. We're going to cover some of the libraries today. And these are resources to learn about all the other things that we're not going to learn today. I can put them back at the end. But you can search for NVIDIA Accelerated Computing Hub, and then you will find a lot of content in there that is more like CUDA Python specific things. So hopefully now, if we go to where we were, I'm going to check Lunchables was here. View. No, where was mine? Actually, maybe in GPU. Okay, so if you still have when you click the deploy, you should be able to see a button that says Access Notebook. So click on there, and hopefully that will get us a Jupyter Lab. And I'm gonna make this bigger. So